In this video, I want to go over installing Klipper firmware on the Elegoo Neptune series of 3D printers with the MakerBase MKS Pi single board computer. Just to get it out in the open right away, I have no affiliation with any of the companies I will be speaking about in this video, and in fact, the MKS Pi kind of sucks in some ways, but the board does work well. I have two of them and they are a very good way to run Klipper, but that isn't without some minor issues. The Pi TS35 screen, as mentioned before, is absolute garbage and unresponsive, so I would recommend a different screen. This is where MakerBase themselves kind of suck. They don't respond to emails, their MKS Pi GitHub page is kind of like a ghost town, and their HDMI resolution support for non-native sizes is just not there. A 7-inch HDMI touchscreen from Amazon or AliExpress will work, but it works at an interpolated 1920 by 1080 resolution instead of the native 1024 by 600. And the 5-inch variant of this display simply won't turn on when connected because of its 800 by 480 resolution. The Big Tree Tech Pi 4B and CB1 combo claim to have resolved this issue, but I don't have one of these to test out. So why Klipper? For starters, Klipper is great for the tinkering community. You don't have to constantly compile firmware to make minor changes. You simply flash the Klipper binary onto the motherboard and everything else is handled from a configuration file. There are tons of resources available for customizing Klipper, and whenever you create a new function, there's a link to the online documentation that magically pops up in the editor. The integration of Klipper Screen and the popular web UIs is practically flawless, and thumbnails pop up pretty much instantly out of Prusa and SuperSlicer. Because of the offloading of data to a more powerful processor, Klipper-based machines can typically move faster and smoother. There's input shaping and accelerometer tuning available with an ADXL345, and lastly, the adventures of Marlin 2.1.2 on my Neptune 2 was tumultuous at best because of bugginess in the user interface, and the D-Win screen that came with my Neptune 3 was lacking in features. The MakerBase H43 I made those videos on are a glimmer of hope for the community that want to remain loyal to Marlin and the Elegoo-based firmware updates, but the web UI integration with Klipper Screen just gave me that ooey-gooey feeling I never got from running Marlin systems with Octoprint. Before I get started, just a word of caution that Klipper is not easy firmware to get into. You can't just start installing things without knowing what to do. If you don't spend the time to learn the system, it will not be an easy task. I build CNC machines with one of the most difficult to get into software packages on the market, so Klipper wasn't all that hard to figure out. Your mileage may vary, however, and if you aren't willing to lose a little sleep trying to figure out why something isn't working, you're better off just using your printer the way it came out of the box. That being said, modifying your machine in any way can result in dangerous consequences such as burning your house down or dying a slow, painful, and embarrassing death. Nobody wants to see you charred medium well in your pink Christmas underwear, so please be careful. To get started, we're going to need some hardware. We need the motherboard that we will be flashing with the Klipper firmware, and in our case, we'll be using one of the ZMP Robin Nano boards supplied with the Neptune printers. We need a device that can run Linux, which can be a laptop, a single board computer, and in our case it's the MKS Pi. We can use an old client like a Dell Wise, a Zima board, or your dusty old porn box that's still got a version of AOL 9.0, Napster, and some bootleg copies of Adobe Flash from LimeWire that somehow sent your data to some guy in the Philippines. You'll have to install Linux on any of these to get it to work, but that's usually done fairly easily these days because of the installers available with each Linux distro. Optionally, you can add a touchscreen display to your device because Klipper Screen is pretty friggin' nice. You'll obviously need a 3D printer to do all of this on, and a USB or UART cable to connect your device to your machine's motherboard. In our case, the software that we'll need for this installation will be the MKS version of Armbian with Klipper pre-installed on it, a Klipper bin file to load onto our motherboard, PuTTY to SSH into our Pi board, but this is optional, considering Windows has an SSH function built right into the command prompt. And lastly, a program called WinSCP, which allows you to view your Linux file system in a point-and-click environment, much like Windows File Explorer. So with that all being said, let's get down to business and start configuring our Pi. So as I mentioned in one of my previous videos, if you go to the MKS Pi GitHub page and you scroll down, you'll find the system image download link right here, which will let you download the zip file that has the Armbian image on it that you need. This comes with Klipper pre-installed, so there's not really much you have to do, but there are some updates that you will do after you start running for the first time. To burn the image, you can use a program like this Etcher program here, and in my case I use Raspberry Pi Imager. Once you download the file, you can go to Choose OS, scroll down to where you see Use Custom Image, Find the MKS Pi Armbian image that you downloaded, hit open, choose your storage medium, and in my case I'm going to be burning it to an SD card just as an example, and then click Write. It'll prompt you to erase the data, just hit yes, and then we wait. It'll burn the image to the drive, and then it will automatically remove the hardware. So once we're done with this, we actually have to remove the hardware and reinsert it so we can access the boot files. Okay, so we've burned our image. We'll hit continue, and that's just to let us know that the chip has been ejected. So again, we'll manually eject the chip, reinsert it, open up the boot folder, go down to the WPA supplicant WLAN0.conf, open that up with your program of choice, change your country of origin. If you are not in Great Britain, change it to, in my case, US. Come down to the SSID and make it your SSID for your home network, and then put in your password for access to your Wi-Fi. Once you do that, save the file. From here you can eject the SD card or your eMMC module. It comes up the exact same way. Insert it into your MKS Pi and power it on. The MKS Pi actually takes either 12 or 24 volts on this port right here. This is a JST XH 2.54 connector, but you can get away with using some DuPont wires because the pin size is about the same, and DuPont connector's form factor is a little bit smaller, so it will fit inside of here. The JST XH connection will lock in place. The DuPont just kind of friction fits in on those pins. You can power this directly from your power supply, or in my case, what I'm doing is I've got both of my machines tapped into one of the 24 volt sources available on the motherboard directly. So I just have a wire going from the motherboard to the Pi. If you have the eMMC module, it will plug in here. This is an older picture of the version 1.0 that didn't have the eMMC module, but it plugs in right here. If you're using the SD card plugs in underneath the SPI interface right here. If you want to run an accelerometer, the ADXL interface is right here, and there is some reserved GPIO pins in this area here. I like to run my machines off of the UART pins that are right here. And if we look at this graphic, on the ZMP Robin Nano V1.2 and V1.3 boards, this source right in the corner, this will provide 24 volts to power your Pi. And the UART pins are these 4 unsoldered connectors right here. There's a 5 volt source, a ground, a TX, and an RX. All you need are the ground, the TX, and the RX, so you can solder 3 pins onto the board here, and then use a DuPont connector or a JST XH connector to connect this to the UART pins on the MKS Pi. These pins correlate to pins available on the Wi-Fi header, so you can use some DuPont pins to tap into the TX and RX and ground on here. If we look at the Neptune 2 schematics right here at J17, we can see that pin 1 is 5 volt, pin 2 is ground, pin 3 is TX from D1, pin 4 is RX from D1, and that links to the Wi-Fi module here. You can see that the TX, the RX are both tied to the D1, and then you can have a ground on this pin 15 right here. So just another quick word about the Wi-Fi chip. I did find that the Wi-Fi module that comes with the MKS Pi as part of the package works very well. But I did try a different version of the exact same brand. The provided one is a ComeFast 810. I tried the ComeFast 815 and it didn't work. Right here on their GitHub page, it does say some information about a Wi-Fi adapter. You have to use one that's based on the RTL 8188 CUS, blah, 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 blah. So be careful if you don't buy the module. I highly recommend buying the module because the module does work. If you're not using an MKS Pi, if you're using the Big Tree Tech Pi 4B and CB1, it has onboard Wi-Fi. And mileage may vary with your other alternative options. Once you power up your MKS Pi, give it a couple minutes to actually get its bearings, and then go to your router configuration and check out your attached devices. In my case, I could see the MKS Pi is on IP address 192.168.1.5. I can test that out by going to command prompt and typing in ping 192.168.1.5. And you can see right here, it's making contact, ET phone's home, and everybody's happy. The stock installation of Klipper on the MKS Pi comes with Fluid installed, and Fluid's installed on port number 80, which is the default port that a web browser will try and attach to when you put in the IP address into the address bar here. So if I put in that address of 192.168.1.5, chances are I'm going to get Fluid to come up. When Fluid comes up, you'll get a warning that says MCU is not ready. In my case, it's already attached, so it doesn't really give me any error messages. Once you have Fluid come up, you're pretty much halfway there. If you're not using a version of Linux with Klipper already installed, you can use the Kaya installer script by going to the Kaya GitHub page, scroll down, copy these 3 lines into your Linux command line, paste those, and just let it run, and it will run the script. In the case of the MKS Pi, it already has Klipper installed, so the Kaya script is already there. In order to get to the Pi to run the script, either way, you have to SSH into the Pi. You can do that with a program called Putty, and simply type in the host name or the IP address of the Pi. I've been having some issues with my host name not resolving, so I'm just going to use the IP address. Port number 22 is proper. As long as you have ping, you should be able to get SSH. Hit open. It'll ask you to log in. The default username and password is MKS, and the password is MakerBase. All this information is available on the MKS Pi GitHub page. Once you have Klipper installed on your device, you then have to create a binary file to flash to your motherboard. On my GitHub page, I have links to a binary file for the Neptune 2 and the Neptune 2S with the V1.3 motherboard. I also have binary files for the Neptune 3 and the Neptune 3 Pro. I've also got configuration files for all of the aforementioned machines as well. But in some cases, you're going to have to compile your own motherboard binary, and you're going to have to learn how to manipulate the options in the printer configuration files in order to add custom settings and what have you to your existing machine. Now is a good time to install a program called WinSCP. If you go into the WinSCP official site, download and install WinSCP. That will give you an interface that lets you look through the Linux files on your Windows computer. When you load up WinSCP, in my case, I've got the split view here. I could see my root folder information on the left. I could see my Linux files on the right. If I go to New Session, New Site, and I type in the host name of 192.168.1.5 with port number 22, just like we did with the Putty program, put in our MKS username and our password, hit login. You'll then see on the right-hand side all of the Linux files that are available on the MKS Pi. These are actually the files that you don't see when you put the SD card into your Windows computer. So from here, if we go into this Klipper folder and we go to config, you can see inside of this config folder that there's a whole bunch of different generic and example .cfg files. These CFG files are printer config files for various printers. So if we scroll down far enough, we will find one for the Elegoo Neptune 2 right here. If we double click on that file, it'll open it up in the WinSCP editor, and we can see right here all of the information that is needed to flash a V1.2 and a V1.3 board bin file. If I SSH back into the Pi and I go to CD space /Klipper, hit enter to go into the Klipper subfolder. From there, type in make menu config. This will open up the Klipper firmware menu configuration screen. This is where you set up your microcontroller architecture, your processor, bootloader, and some other options to get the Klipper binary ready to flash to your motherboard. So for the v1.2, we have to compile with extra low level configuration, STM32F103. So if I go back to my command prompt, make menu config is still called up. If I hit enter to put a little star next to enable extra low level configuration, from there I can cursor down to microcontroller. I can choose the microcontroller that I wish to create a file for. In our case, the STM32 series. Come down to processor model. Let me compile one for the v1.2 because I don't have one. So I'll cursor up to STM32F103. I'll check that. Hit enter to confirm. Take a look at the other options on the left here. We want to use serial US ART3. So cursor down to communication and US ART3, PB11, PB10, and that will allow us to use the USB port. The bootloader offset, we need to use a 28 kilobyte bootloader offset. And everything else seems to be pretty hunky-dory. If you want to use the UART pins on the MKS Pi tied to the pins on the Wi-Fi connection module, as I mentioned earlier, what you'll have to do is you'll have to find the pins that correlate to that inside of the schematic file that's available on the official Elegoo GitHub page. And this is going to be different for every model of processor, but it's going to be similar for every board that you create the bin file for. So this is interchangeable for every series of STM32F103, in our case here, for the Elegoo series of printer. But this processor is used differently for different brands of printers, so these pins may not always be the same. In the case of the Neptune 2, if I scroll down to the J17, we want to find the TX and RX D1. So we can scroll back up to the microprocessor overview here, and we can search for TX and RX1, which is PA9 and PA10. So we have right here TX D1, RX D1, PA9, PA10. So back in our menu config, if we were to choose PA9, PA10, this would allow us to use the UART rather than having to use PB11 and PB10, which if we look here is TX D0 and RX D0. These are the communication pins for the serial port. My recommendation is to get your machine running on the USB port first. Once it's running on the USB port, from there, go back into your make menu config and create a new bin file for the UART. You can't have both, so you have to compile firmware for one or the other. But I did have some little issues getting the UART working on my machines, so my first plan of attack was to get it working on USB, and then from there, the UART just kind of came naturally. Once you have that all figured out, just press the Q button to quit. It'll ask you if you wish to save the configuration. You type Y for yes. And then from there, just type in the word make and hit enter. It will compile the binary file for you, and it will call it Klipper.bin. If we go back into WinSCP and we go into the Klipper folder and we go to the out subfolder, Klipper.bin file will be right here. We can take that, right click on it, copy it, go into our left side here, which is our PC, choose where we want to place that binary file. If we have an SD card plugged in, we can go to the SD card that's plugged in, paste it, hit OK, and then rename that by going right-click, rename. For the Neptune 2, we're going to call it Elegoo.bin. If this were a Neptune 3 or a Neptune 3 Pro or a Plus or a Max, we would call this capital letter ZNP underscore Robin underscore nano.bin. Each board has its own specific file name that needs to be used in order to flash the binary to the board. So you'll have to look that up for any other brand of printer. Once you have that on there, you simply remove the SD card, place it into the SD slot on your printer while it's powered off, turn the power on, and wait about 3 minutes. Once that's done, the Klipper binary will be flashed to the motherboard. You can plug in your USB port, and in a perfect world, we should be almost ready to see our interface. The next step that we have to do is we have to make sure that our printer configuration is set up properly for communication between the printer and our external device. If we go into configuration and we go to this printer.cfg, the printer.cfg that will be inside of Klipper by default is not going to be the one for your particular printer. In that case, we can do a couple of things. If we go into WinSCP, under the Klipper underscore config folder, here's where we can see our printer.cfg. We can open this file either here, or we can open it up in the web UI by going into this little configuration icon here. Click on printer.cfg. Once we're inside of here, what we'll do is we will find the configuration that correlates to our printer. Again, there are some pre-made configurations under Klipper config. If I come down to the Elegoo Neptune 2, if I open this, I do a Control A to select all, Control C to copy, close this out, go back to this printer.cfg. If I do a Control A and a Control V to paste, I now have the configuration for the Neptune 2 inside of the printer.cfg file that Klipper is looking for. I'm not going to save this because I'm not looking to overwrite my config. Another way you can do it would be to go into the config, choose the config that you want, do a Control C to copy, go into Klipper underscore config, do a Control V to paste it, hit OK. From there, you would delete this printer.cfg and go into the new config file, right-click on it, select rename, and call that printer.cfg. So there's a couple ways that you can get a configuration working inside of here. So as a side note, another quick way of SSHing into our device is to simply go to Windows Command Prompt and type in SSH, the address that we want to SSH into, put a dash lowercase l, and then the username that you wish to use, in our case, MKS. Hit enter. It's going to prompt us for the password. We put in our password, hit enter, and you can see right here, it SSHs right into the board just like it would with PuTTY. If you have any problems with SSHing into the device with PuTTY via the Wi-Fi, there are steps on the MakerBase GitHub page that walk you through getting into it with your USB cable. The USB-C that's on the MKS Pi is only there for debugging purposes. It's not there for powering the Pi or anything like that. But you can use that to SSH into the board and then run the network manager that's built into the Pi. With different devices, there are different ways of accessing the device. There's also an Ethernet port available on the Pi that you can use to SSH into it via a hardwired connection. So there are some available options to access the settings for the Wi-Fi in order to get this thing on full chooch, if you will. So let's recap what we've done so far. We've downloaded Linux for our device. We've flashed the SD or eMMC chip with the Armbian distro using the Raspberry Pi imager. We've changed the WPA supplicant WLAN 0 file for the SSID and password for our Wi-Fi network. We've downloaded and installed PuTTY and WinSCP. We've acquired a .bin file, either from a GitHub page from somebody who's kind enough to share theirs with you, or by using the make menu config application. We then flash the bin file to our motherboard. We acquire a printer.cfg file, and it could be one of the included printer.cfg files. We could have found it on somebody's GitHub page, or we can create our own. We then replace or paste the new printer.cfg with the one that's in the Klipper _config folder. And now we should be ready to power up the Pi and let it rip. So now let's talk about the interfaces that are available for Klipper. The pre-installed interface for the MKS Pi is Fluid, but you can also install Mainsail, which is another web UI. Looking at them side by side, they're very similar to one another. They offer the exact same functionality, just in slightly different ways. All of our major features are available on this left side bar here for both. We have the dashboard or the home screen, which shows us an overview of everything that we choose to look at on the home screen. All of these pages are customizable. We've got a console view, which opens up a large terminal. And you can see that there are slight differences. But you could do things in the terminal just like you would if you were running Octoprint, if you're familiar with that. If you want to do some G commands, you could send G commands. If you want to check the status of your BL Touch, for example, we can type in query _probe, send that, and we can see right now that it's in the open state. When you first start Klipper, you're going to get an error message saying printer's not ready, host software is attempting to connect. If the software is able to find your board and connect, that message will go away. If that message does not go away, what you'll have to do is you may have to tweak around your USB settings or your UART pin settings by going into your printer.cfg, and under your MCU section right here, you can see I've got two different serial sections, but one of them is preceded by this little hash. The hash denotes a comment inside of the printer.cfg file or any of the CFG files. If I were to take away that hash and hash out the one underneath it, I switch from device/ttys0, which on the MKS Pi is the UART section. And now I'm enabling the /dev/ttyusb0, which is the USB section of the MKS Pi. If I hit save and restart, it's not going to be able to connect because I have the firmware set up for the UART pins and I don't have a USB cable plugged in. So you'll see this error message until the printer actually connects. Every time you make a change to your CFG file, you hit save and restart, or you can do a restart Klipper or restart firmware. When you're using the serial port, if the /dev/ttyusb0 doesn't work for your particular device, what you may have to do is you may have to explicitly specify what the serial ID is for the port that is connecting your board. To do that, connect the serial cable from the device to your printer, wait a couple of seconds, and then SSH into your board. I'm going to do this through command prompt. I'll just type in SSH, give it the address, -L, MKS, put in the password, and then from there, I can just do an ls/dev/serial/by-id. So ls space /dev/serial/by-id. Hit enter, and we can see right here the ID is USB-1A86_USB blah blah blah. If you don't want to try and remember all of that, what you can do is you can just type in ls space /dev/serial/by-id/USB-1 and then press tab. That will backfill the entire string of what you need into this line here. You can then grab that with your mouse simply by clicking and dragging, highlight it, use Control-C to copy, come back to your printer.cfg, highlight the /dev section, Control-V to paste. Once you have that pasted in, save and restart, and chances are, if it didn't connect with the TTY USB 0, this will get you at least one step closer. Anytime you have issues with the printer not connecting, you can look in the log files over here. In this case, we would look at the moonraker.log file. And if we scroll to the bottom, we can see that we have some errors right here. It's not connecting. It's unable to get the machine information. If I change that back to use the UART pin, you'll see that after a few seconds, the machine connects and the error message goes away again. If I go into the moonraker.log, I go down to the bottom, you can see that it now connected. It goes through the configuration, and if I wait long enough, it'll actually fill that log file with more information eventually. Looking at the configuration section inside of Fluid, or the machine section inside of Mainsail, you'll see that I have the configuration files folder, which is here, and then the other files, which is here. I can go into logs and look at my Moonraker log. I can look at my Fluid error log, Clippy log. Under docs, I can go into a document file, and I can look at some document files that pertain to, say, for example, BL Touch. We can look at the document file for the help for installing BL Touch. Another nice thing about Fluid is if I go into printer.cfg, all these blue links here will bring me to the online help section of the Klipper website. It shows me the basic rundown of what each option is available inside of this section with square bracket. It shows you how to set up your stepper motors, shows you all the available options for setting up your stepper motors. So that's one thing I like about Fluid over Mainsail, but they both have their strengths. If I'm setting up, for example, a BL Touch, I know that I have to set up a BL Touch section. If I were using the strain gauge on the Neptune 3, I would set it up as a probe. So there's two different sections that can be set up, but they kind of have very similar features. I have my bed measuring and my probing stuff set up in this bedmeasure.cfg file, which is included in the printer.cfg with the square bracket. So I've got square bracket include bedmeasure.cfg, which then includes that file as part of the configuration. We can see right here I have a BL Touch section. You have to know what pins connect what to what inside of your motherboard. And again, you can access that information by finding the schematic files, or you can open up Marlin firmware for that particular board, and you can see what the pin designations are for that particular piece of hardware. If I click on this BL Touch documentation, again, it brings me to online help. If I didn't have a section and I just put square bracket and I put something, close it out with a square bracket, you can see right here, view something documentation. It may or may not find what you're looking for, but it always comes up with a link to the Klipper website. Because it couldn't find something, it just went to the configuration reference main page. If I were to set up a probe, I would put square bracket, probe, close the square bracket, and it says view probe documentation. Click on it, and you can see again right here, I have information for the probe. Same thing with safe Z homing, bed mesh configuration. Click on any of those, and you get a help menu. But also, there's a config_examples that you can go to, and this is the exact same as going into that config file via WinSCP, and you can find your printer configuration here. You can do your Control-A, Control-C, close, open up this printer.cfg, Control-A, Control-V, and now I've just changed my entire printer configuration for a Focus Odin 5. I don't want to do that, so I'm just going to close out. If I wanted to save that, I would just hit save and restart. Every time you make a config file change, save and restart. And what that'll do is it will reinitialize the Pi, and it will re-establish a connection with the motherboard. Once Klipper connects from your device to your printer, the first thing you're going to want to do is just update everything. So if you go down to settings in Fluid and you go all the way down to the bottom, or if you click on the software updates, it will bring you to the bottom of the page. Click on the check for updates link right here. It'll go through and it'll check to see if everything is up to date. And anything that's not up to date, you can either click on the link that says to update here, or you can just hit update all, and it will update everything, and you'll be up on the latest and greatest interface, Klipper software, etc., etc. So let's say I wanted to test out the functionality of my BL Touch. The first thing I would do is I would go into my configuration. I would create the BL Touch section, give it the proper sensor pin, control pin information, and then there's a couple of different options that may or may not be required for using a BL Touch, such as X offset, Y offset, Z offset. If I were to comment out Z offset, hit save and restart, when the system restarts, it's going to throw an error because you need a Z offset to have a BL Touch. So it says right here, option Z offset in section BL Touch must be specified. Once the underlying issue is corrected, use the restart command to reload the config and restart the host software. So Klipper will not let you move forward until you've resolved any issues within Klipper itself. You can see right here, even though I did that in Fluid, Mainsail's not happy either because the Z offset section is missing. So I'll go back in, go back to bed measure, take out that hash. But now here's something interesting. You can see that the X and Y offset values are optional. So if you have the proper information, some of it is just additional, like the stow on each sample or probe with touch mode. These two options, if you go into here, you can see in the help menu what needs to be provided and what will have a default value if you don't put anything in. Really makes you want to try it out, doesn't it? Anytime you're done, hit save and restart. It will take a couple seconds. It will get the board ready, and it'll connect. So let's try to trigger our pin. We've set up our BL Touch section. We've put in the wiring. We powered on. The BL Touch goes through the 2-click test, and we have a solid red light with a little faint blue light indicating PWM. That's when the BL Touch is in a happy state, and now we can actually test the status of the actual probe. There is a BL Touch debug section. You have to search for that. You have to search for either BL Touch _debug or pin _down. You can see right here, the last search term I put in was pin _down, so here it is. So if we take this command right here, and we copy it, Control C. We go back to the console, paste it, and we replace command with pin underscore down. I don't know if you heard it in the background, but the pin on my Neptune 3 just came down. If you click on any of the commands here, it'll reload it into the console. I can change that to pin up. It retracts the pin, and everybody's happy. If you do a query probe, you can see right now it's open. If you do a BL touch command pin down and do a query probe, right now it's still open. If you then walk over to your BL touch and you hold it with your finger and trigger it, when you do a query probe again, it'll say closed, or it should say closed. If it's connected properly, it will say closed. And then you know that it's ready to run. So there's a lot of nifty little features inside of the console that you can use for testing and debugging and making sure that your printer is set up the way that you want it to be. Inside of the job section here, this is where you can upload files for printing. The history page will show you the history of things that have run on your machine. In the case of my Neptune 3, I actually haven't printed anything yet. I can switch to Neptune 2 because I've got both of my printers set up under this guy here. Once I'm logged into one printer, I can add another printer simply by going Add Printer, put in the address of the other printer, and give it a name. So before I go off on too many more tangents, I'm going to end this video right here, as there's probably a ton more things I could say, but I'll keep that for another video. I do hope you found this to be a useful resource in getting Klipper installed and running on your device. Please keep in mind that there are other prepackaged distributions you can use for various devices, as well as the Kaya script, which I plan on doing a video on as well. Please let me know in the description what else you'd like to see in future videos, and be sure to subscribe to the channel if you enjoy this type of content, ring the bell for all of the latest news and updates, and give my little buddy Cheeto a like, or else. Thanks for watching, and see you soon.